All right, welcome back, guys. Um, in this section, we'll be discussing balancing my chemical equations. Balancing my chemical equations. So, as an example, tiangana equation na be N2 gas plus H2 gas to form NH3 gas. So nitrogen gas, I go and react in the hydrogen gas to form ammonia gas. I mean, for your information, equation E, rather this process, ima chedwa the Haber process. Ima be essential to my industries or manufacture ammonia fertilizers, right? My guys in my chula Haber-Bosch process. Haber-Bosch process. So anyways, I said na way I was up on Zaba not what the Haber process in right? We're here to balance this chemical equation. So the question would be balance the following chemical equation. Namba ilimba na mene ilimba moja. N2 gas plus H2 gas to form ammonia gas. As it is, see the balanced. Then the way now the debang balance. So how do you do that? You do that by realizing kuti species you don't say emanating more reaction here. By species I mean kind product, kind reactant, reactants with my atoms, with my compounds. Right? Sorry, my elements, my compounds. All those are species. An element can be a species in a chemical reaction. A compound can be a species in a chemical reaction, right? Species in a chemical reaction. Species in a chemical reaction can be elements or compounds. So those are species in a chemical reaction. And they will also bring a balance. You understand, Guti? This is a species, this is a species, and this is a species. Right? Ammonia, say. This is a species. Right? Do you understand, Guti? Kumbuyo kwa N2 as a species. Kuli number ina kama sitiwiziwa. You call that number a coefficient. Kumbuyo kwa H2. Kuliso number ina kama sitiwiziwa. You call that number a coefficient also. Kumbuyo kwa ammonia. Kuliso number ina kama sitiwiziwa. You call that number a coefficient. Right? So, what do you do? My coefficient, you simply assign variables to them. Kumbuyo kwa nitrogen, there's a number x. We don't know what the number on the chart, so we just write it as x. X and 2. Timena kuika gas up. Komabe zimango juu itazolemba, bamedi kubanga balance. So you drop that guy, bamedi kubanga balance. This is the sort of cameras. Plus, again, hydrogen. We know who the hydrogen, ali number it has a coefficient. So what's a variable? Say y. Okay. Hydrogen are in the coefficient. You call it y. So we understand the nitrogen has a coefficient. We don't know it. It might be 5, it might be 6, it can be 7, 8, 20. So for that reason, then going out in the x. Hydrogen, same thing. I do coefficient, kind 20, kind 50, kind 3, kind 2. So the easier for that reason. Then going out in the n and the y. Right? We do the same to ammonia. Ammonia, pambuyo pake apa palinso namba imene tisakuyitani tisakuyidziwa. So what do? Tingoyipanganso represent ndi yani, ndi variable. Same thing. Okay, let's say maybe d. Basito ndiwe yakupatsa equation yoti uyipange balance osavutika ya ikopera equation yo without ma states of matter. Ma states of matter ndachina gas timayika omwaja, right? Ndiwe ikopere without these guys, ma states of matter. Koma kumbuyo kwa species iliyonse, kumbuyo kwa element iliyonse, kumbuyo kwa compound iliyonse, mukemeka equation yako uyikepo ma variables ina x, y, d amenewo yakusangalatsa, amene ukufuna basito. From there we can now apply the law of conservation of mass or matter. Some people call it that. The law of conservation of matter, the law of conservation of mass, you name it. Apply. So what do we mean? The number of atoms on the reactant side of the chemical equation must equal the number of atoms on the product side of the equation. Chifuka matter cannot be created or destroyed. Matter singapange destroy, sitingaononge matter, sitingapange matter out of nowhere. It simply rearranges itself. Ngati kuti nanda ina nitrogen uko ina hydrogen angopwasuka kena kwazipangaso rearrange ndikupanga form yani ichi. Sitinapange create matter yanyowani, sitinapange destroy matter ina iliyonse. Matter yomwe general kuno kuija yangozipanga rearrange ndikupanga form yakutiko yauko. Full stop. That ndizimezachitika. So the total number of nitrogen atoms ku reactant side kuno, chimeji masiyanisa reactant side and the product side is this arrow paja. So the total number of nitrogen atoms ku reactant side kuno must equal the total number of nitrogen atoms ku product side. So reactant side, product side, right? Equation, yeah. Kupanga katebo kuoneka yoncho. Something like that. Okay, so for nitrogen, for example, for nitrogen, reactant side, we do have how many atoms? Tidanga coefficient E multiplied by subscript. Imene ipa nitrogen ipo. So we do have 2x reactant side. Ku product side, nitrogen. Alipo so inangara palibe, so we move on to the product side. Didindi 2 got the coefficient. Subscript ababa ndi 1. Chabe kuti sanarani sanalembedwepo. Right? Ndilipanga d times 1. D times 1 is simply d, and the equation becomes 2x equals d. The total number of nitrogen atoms on the reactant side has equaled the total number of nitrogen atoms on the product side. Right? What's that? Hydrogen. We do the same. Apa hydrogen valibebo, apa alibo, apaso alibo. We do the same. Total number of hydrogen atoms on the reactant side, the coefficient D times subscript here. So 2 times y becomes 2y. Go product side, total number of hydrogen atoms is this coefficient D multiplied by subscript y hydrogen here, which is 3. This becomes 3D. Applying the law of conservation of mass, which says that the total number of atoms on the left-hand side or the reactant side must equal the total number of atoms on the product side. We say that for hydrogen, the reactant side with 2y atoms, the product side with 3d atoms. That's it. So in the end, we have 2x equals 3d and 2x equals d and 2y equals 3d. titongosankha equation iyi ndiyophweka pa ziwiri izi, and then we could say let x equals 1. If we let x equal 1, then 2 times 1 becomes d, imene, or 2 equals d, or d is simply equal to 2. Right. Equation in 2y equals 3d, and we know that d equals 2. Ninkani yongolengano 2 uja kamusi amene pali d. From your algebra, apa titawanga divide both sides by 2, such that y becomes 3. 2 and 2 yapanga cancel, uyuso ndo yapanga yani apana cancel. In the end, we have our values. D equals 2, y equals 3, and we said x equals 1. So equation ija tinayamba kuti x n2 plus y h2 to yield d nh3. Tipangano substitute back my values aja munyani mu equation. X is 1, sitima muikapo tingolemba kuti n2. Y is 3, d is 2. Apa pande kuti the equation is balanced. And that's where we now bring back my subscript aja, rather my original, my states of matter aja. This is gas, this is gas, this is gas. Right. Now the equation is fully balanced. One way in balanced N2 3H2 gas to yield 2NH3 gas. Right. The equation, the chemical equation is balanced. All right. See you in the next video, my guy.